Welcome to this anatomy revision video. Today we're going to be looking at the structures, relations and functions of other anatomical features of the lungs. The lungs are a bilateral structure located on either side of the thorax. Each lung is surrounded by a pleural cavity formed by a fold in the visceral and external parietal pleura. The pleural cavity contains a pleural fluid that helps prevent the lungs sticking to the chest walls. This enables the expansion and collapse of the lungs during respiration. The medial surface of the left lung is close in proximity to a number of mediastinal structures. These are structures which are located in the central part of the thorax. These include the heart, and this also includes the aortic arch and descending aorta, as well as the esophagus running down the back. The aorta leaves this characteristic arch-shaped depression on the posterior surface of the left lung. The medial surface of the right lung is also in close proximity to the esophagus and heart, while also being close to other structures on the right of the thorax, including both the superior and inferior vena cava. So the left lung has two lobes. These are the inferior and superior, and these are divided by the oblique fissure. Whereas the right lung has three lobes, the superior, inferior, but also a middle one, and these are divided by the oblique and horizontal fissure. The bronchi and blood vessels enter lungs through the hilum. This is depression on the mediastinal surface of the lungs, whereas the pulmonary artery, the two pulmonary veins and the bronchus also enter through the hilum. The bronchi tree is a term we use to describe the branching structure of the airways of the lungs, from the bronchus to bronchi and eventually to bronchioles. The bronchioles will give rise to alveoli. These are the site for gaseous exchange. The alveoli are surrounded by an extensive capillary network, which is supplied by deoxygenated blood from the pulmonary arteries. Once the blood is oxygenated, it leaves via the pulmonary vein and goes back to the heart. The diaphragm and external intercostal muscles are the primary muscles used in inspiration. During inspiration, the diaphragm contracts and flattens, and the external intercostal muscles also contract. This increases the volume of the thoracic cavity, therefore lowering the alveolar pressure, causing air to move into the lungs down a pressure gradient. The primary muscles are used in both quiet and forced inspiration. Forced inspiration also requires the secondary muscles as well though. These include the scalenes, upper respiratory tract muscles, and the neck and back muscles. During expiration, the external intercostal muscles and diaphragm relax, decreasing the volume of the thoracic cavity. This means the pressure inside the lungs increases, forcing air to move out down the pressure gradient. In addition, quiet expiration is a passive process, relying mainly on the elastic recoil of the alveoli. Forced expiration, though, requires secondary muscles with respiration. These include the internal intercostal muscles and the abdominal muscles. The structures of the lungs are also specialised for their function. For example, the trachea and bronchi are reinforced with cartilage. This is to prevent their collapse during respiration. Also, the alveoli increase the surface area of the lungs to improve the efficiency of gaseous exchange. Thanks for watching the video. I hope it helps you with your anatomy revision, and good luck with the exam. You go get 'em!